What is bughunter360? Well, it's a vision of a possible future that has become possible thanks to opening up the use space. So use space means that the European Union will be allowing drones. And as a consequence of that, there will be many delivery drones. And this in turn would allow, in theory at least, for a farmer to order a drone to come and eradicate the pests on his field. So he would basically press a button on his phone, and then some possibly delivery drone company would release a drone which would come to the field and use some kind of optical system, which in this example, this is the Zipline drone, a well-known delivery company. We could easily fit an optical system inside its little basket, which they call the droid. And that optical system would consist out of a laser, a Galvo scanner, and some electronics. Basically, it can shoot a laser at an insect and there, in that way, kill the insect. One target insect that would be likely very suitable for this is the Colorado beetle, because it exhibits the correct biological behavior. The adults like to spend a lot of time sitting on top of the plant, and so do the larvae. It's also quite a difficult pest to work or to combat as a farmer, because it becomes resistant to many different types of pesticide, and it costs around in product to, if you want to spray against this insect, 250 euros per hectare. So it does cost an average farmer of 100 hectares, 25,000 per year. So that's a lot of money to work with. And globally, the market is around 1 billion for this insect. The main technical challenge is the event camera. Well, there are three technologies: lasers, beam steering, and seeing. Seeing is likely the most challenging difficulty. But it's good that a new kind of technology is being developed, which is called event cameras. And basically, this is a camera that can see at a much higher frame rate. So, for instance, we see the cheetah running in a convention camera versus events. This is another type of, another concept of a drone. We've developed several. This type of drone can basically shoot forwards. So it can shoot the insects that it's seeing in its immediate in front of it. And we can see how that works here. So the laser generates a laser beam. The laser beam hits the mirrors of the Galvo scanner, and then the laser beam actually hits the insect. This one could also shoot, you can make it that it shoots sideways. In that way, it can also kill insects that are only accessible from the sides of the plant versus directly from the top. We could even make it's possible that we could make it that we can see insects through the leaves, and we can shoot through the leaves. These things still need to be investigated a little bit, but it looks feasible. Yes, so here we see the laser beam is slowly going towards the insect in this animation, but in reality this is about 1 millisecond and the laser beam is not visible, right? This is just to kind of illustrate the principle. Also, the drone would never stand still. It will be continuously moving, likely at something like 30 kilometers an hour. Here is another possible concept on how you can shoot a laser beam sideways also on the insect. So in this way, it's initially just shooting in front of it, but maybe with mirrors it can shoot sideways. The best solution is not 100% clear. Some research will be needed, but the core technologies are there. So here we see an alternative to using delivery drones, which is to roll out our own solution. And as you can see, this is a possible robot that would be able to swap the battery of drones. So basically one big farmer or a set of farmers could join together, and they would make a concrete slab. And then once you have a concrete slab, it's not that difficult to have a small robot that can actually approach the drone and swap the battery from the top, using, for example, mechanism wheels and a Z-stage electromagnet as shown here. This whole project fits very nicely into the European Green Deal, whose one of its main objectives is to reduce pesticides by 50% by 2030. I believe the return on investment in this type of in this project could be very good for any potential investor, because it has it can fail fast, right? So either the technology is feasible or it is not, and with a small amount of budget, this will be apparent very quickly. But already 2 professors have verified that this technology, the state of technology, is slightly ripe. And so if you do the numbers, it seems to make sense and be feasible. And if the technology is feasible, then the market for it is I think, very big. As I said, for Colorado beetle alone, it's about 1 billion annually, and then there is a whole other set of insects that are also suitable for this technology. I've made this video to also get some feedback from the community, from engineers. So what do you think about the designs? What do you think about the concept? Do you feel this is possible or not? Let me know and share some comments below, and I look forward to reading them.